then go to your college class. How about that?
I'll just send you a text.
Okay, okay. All right, so let's review. Is this a number one? Is this a one side or two side? That's a two side because there's no plus and minus. Okay. First thing we do, try direct what? Substitution. I plug -1. What do I get in the denominator, class? 0. So I need to use a toolkit strategy. Let's see here. What comes to your mind there? Factoring. I'm going to factor at the top. I'm going to come down here and factor 2x squared plus 2x minus 3x minus 3.
Is this our notebook?
No, it's not. This is something I just came up with. I'm going to take that and plug it up here. I'm going to cancel those out. Now I'm going to try direct substitution. 2 times -1 is what? -2 minus 3 is? Thank you. All right, number 2, I'm going to try direct substitution. 1, 5 times 1 is? 5 minus 1 is? My square root of 4 is? Very good. We always try direct substitution. Number 3. All right. Here I do direct substitution. 3 minus 3 is what? Can't do that, can I? So I'm going to do what technique? Very good. So I'm going to come over here. Am I rationalizing the numerator or denominator, Taylor? And when I do that, I only need to change what sign, Gracie? To a +2. Very good. Alright. Now I'm going to multiply this square root times this square root. That gives me x plus 1. This times this is 2 square root of x plus 1. This times this is -2 square root of x plus 1. -2 times 2 is -4. All over x times this is x square root of x plus 1. X times 2 is 2x. -3 times this is -3 square root of x plus 1. -3 times 2 is -6. What's +1 and -4 give you? -3, okay? Now, we look down here. If I plug 3 back in, I will get 0, but I need to group some stuff here. Can I move that next to that? Yes. And I can move that next to that. All right, now I'm going to factor out of x plus 1. That leaves x minus 3. Cancel that out. That leaves a 1 over all this. Now I'm going to do direct substitution. Plug a 3 in. 3 plus 1 is 4. Square root of 4 is 2. That'd be 1 over 4 is my answer. Are there any questions on that one? Okay, number 4. First thing I do is try direct substitute. Is there anywhere to plug anything in? So what's your answer? Very good. All right, let's go over our homework now. Tomorrow I'll give you a graph. You got to find the limit. You got to find the limit, and then you're going to have algebraic. All this is on your quiz tomorrow. I forgot to put anything about a table, so you don't get stressed by a table. Be able to find it by graph, find it algebraically. Remember, first thing you always do, plug in direct substitution. If that doesn't work, then you're going to try factor, rationalize the numerator denominator, or find a common denominator. If that doesn't work, then you've got to pick a number in, either to the left or the right, or both, if it's one-sided, two-sided, and plug a number in and see if it's going to positive or negative infinity. Do we all understand our strategy? Okay, that's all that. All right, so let's look at our work. All right, number 33. What did we get on number 33, Ms. Spicer? Does not exist. Because if you plug 1 in, guys, you get 0 in the denominator. Okay, you can't do any of the toolkit strategies. You see this is a two-sided. It means you're going to plug 1 into the left and 1 into the right. When I plug 1 into the one in the left in 0, I get positive infinity. If I plug 1 to the right, I get negative infinity. They're going two different directions. That does not exist. Number 34, Emma, what did you get? Does not exist. It's the same way. It's two-sided. I plug 3 in, I get 0 in the denominator. I can't do anything else to that. So since it's two-sided, I plug 1 in from the left and 1 into the right. Number 35. Sean, what you get on that one, buddy? No, that's right. I'm sorry. 35. Jessica, what did you get? Which one? Infinity. Positive infinity. Class, that's a one-sided. We're only concerned about the left, so I pick in the number that's to the left, negative 3. I plug negative 3 in, I get negative 1 over negative 1, which is a positive value, therefore it's going to positive infinity. Number 36, Ms. Sherman. 5 over 2. I try direct substitution. Once I do it, it works. 3 plus 2, or 3 minus 1, gives me 5 over 2, which is acceptable. Number 37. Reese, what you get for 37? Infinity. Very good. I plug 1 in. I get 0 in the denominator. That's a big no-no. Well, then I can use one of my toolkits, right? I can factor. Once I factor, I cross it out. I'm left with 1 over. Once I factor it, I get 1 over x minus 1. I tried direct substitution. Does it still not work? No. So I got to pick a value to the right. I pick 2, and I get 1 over 1, which is a positive value. It means it's going to positive infinity. Okay, number 38, Max. What did you get on that one?
30.
Very good. Positive infinity. I plug negative 1 in. It gives 0 in the denominator, so I'm going to factor it. Cross it out. I still can't do direct substitution, so I got to pick a value to the left. Plug in negative 2. Number 39, is that Moon? 9 over 8. Very good. 9 over 8. On that one, you do direct substitution, you get 0 in the denominator. You use the toolkit strategy factor. Once you factor, though, you can direct substitute. So that's why you could use direct substitution there. And number 40, great. Infinity. Very good. Are there any questions on those? Y'all feel better on those? All right. I'm going to give you 5 minutes to do a checkpoint. This is real simple. It's 4 questions. Because once you cross out and then you do direct substitution, you do actually get a value. Because it's no longer undefined. See what I'm saying? Once I did direct substitution, I didn't get 0 in the denominator. Does that make sense? When you're done, just turn to page 7 and be ready to take notes.
Can we bring this?
Yes, bring it to me. Made a simple mistake. Look at your previous answer. I'm proud of it. Good job. Proud of you.
Right here because it's kind of
Go look at that one right there. Proud of you. Now you need to be quiet on my line because I would think you'd be swapping answers right there. Proud of you. Proud of you, buddy.
I just had them swapped.
Mm-hmm. Proud of you. Are you changing answers?
No, I didn't have it right. It didn't like it was a lot. It's like I'm sitting in the shop.
Good job, bud. Proud of you. Just go look at that one house right there. Proud of you for that. Good job. Good job. Proud of you. Yep, good job, proud of you. 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 Good job. Yes. I'm sure I'm going to miss y'all first few years. No shit, we'll go by so quick. All right, let me post attendance. Our last limit lesson day, and it's real easy. Like, we got to the hard part of this unit. All right, so Noah's at who else? Okay, TJ, Catherine. Okay, let's see here. Sean, go erase your name off the zero period list because you finished your makeup work, please. All right, here we go. Today our learning target is I can determine limits at infinity. So what does this mean? Do you notice down here under the limit, it's going to a certain infinity now. Certain infinity. It's not going to be a number there, okay? Now, page 7. I'm just going to tell you, all this right here is just confusing. We're not going to go by those rules. We're going to go by the simpler way, okay? What kind of functions are these in these limits? What kind of functions? The big name of them. Somebody said it. They're what? Say it. Polynomials. They're polynomials. We have a cubic. We have a what? Quadratic. We have a what? Those are polynomials. Notice, when it's a polynomial. Do you remember when we studied polynomials, guys, that we were all about, okay, the end behavior. If it was even, if it was even and a positive leading coefficient, then both of the ends are sticking straight up. But if the leading coefficient was negative, they're both sticking what? Down. All you gotta do is sketch the picture and look at what's going on, okay? If it was odd, then it'll be going like this, wouldn't it, if it's positive leading coefficient? Like this. So that's all you're gonna do. So on number 1, what's your highest degree there? 3. And it's a positive leading coefficient, isn't it? So you would have a graph that looks something like that, wouldn't you? I would sketch me a graph. It doesn't have to be perfect. You just stretch them. Now, we want to know what's going on as x goes to negative infinity. Negative infinity is that going that way, isn't it? Where's this end going? So, what infinity? That's your answer. Okay, what type of function is this, Josiah? Quadratic. What's the leading coefficient in front of it? Is it positive or negative? Negative. So that means both ends are going to be going what? Down like that, isn't it? So if I was going to positive infinity that way on the x-axis, as I go to positive infinity, what's going on with my y values? They're going where? Negative. That's your answer. You see how easy this is? But do you now understand why I talk about end behavior so much? You've got to know what's going on with the end behavior. All right. Yes, hon.
Sorry, what's the rule for parabolas?
Okay. If the number in front of your x squared or x to the 4 or x to 6, any even, is positive, your ends are where? If the number in front is negative, they're where? Yeah, that's it. All right, let's look at number 3. What type is this, Jake? Quadratic. My leading coefficient is what does that mean? Positive or negative? Positive. So I would draw a parabola. Look like that. As I go, now it says as x approaches what? So I'm going that way, isn't it? As I go that way, where's my y values going? So your answer is positive infinity. That's not bad. All right. Daniel, what type of function do I have right here on number 4? Well, it's not quadratic. Starts with Q. Quartic. Very good. And you know it's going to be something looking like this, isn't it? All right. As x goes to negative infinity, what's going on with this end behavior right here? It's going where? As x goes to negative infinity, my y values are going to positive infinity. Number 5. Sean, what type is this, buddy? Quintic. Very good. Alright, so I got something look like that. As x goes to negative infinity, where's my y values going? Negative infinity. He said, Mr. Richard, what would it look like if it had a negative in front of it? It would be the other way. The other way. Number 6. Brendan, what type is this, buddy? Cubic. Alright. So it looks like something like this. So as x goes to positive infinity, Emma, where does it go? Where's my y values go? Positive. Very good. That's my answer. Are there any questions on how to determine the limit of a polynomial function when you're going to infinity or negative infinity? All good on those? I need a hand signal. Okay, thank you. Now, let's go to rational functions. The limits, they're still going to infinity, but let's look at our rules. Now, we do have some rules here. If it's top heavy, that means the degree is higher in the numerator. It's going to be either positive or negative infinity. We're going to talk about how to determine that in a minute. That's the hard one. It's going to be plus or minus infinity. If it's bottom heavy, that means the degree of the top is less than the degree of bottom. It is 0 every time. If the degrees are equal, you divide the leading coefficient of top by the leading coefficient of bottom. This is very similar to when we did asymptotes. So LC, the leading coefficient of top divided by leading coefficient of bottom. Alright, so on number 7 there, let's look at what's my degree in top there, Jordan? What's my highest degree in the top? 2, very good. Grace, what's the highest degree in the bottom? It's top heavy, isn't it? When it's top heavy, that's the tricky ones, okay? Now you can do this one or two ways. And I'm going to show you both ways, and you can decide which way you want to do this. The other two is straightforward, but this one you think. As x goes to what? Positive infinity. So x going positive infinity. What's the number in positive infinity? I could choose 100, couldn't I? If I substitute 100 in here, just you really don't, you can look at it. If I substitute 100 in there, am I getting a positive or negative value? So it means it's going to positive infinity. Okay? You can think of it that way. If you don't want to do that, then guess what? You can graph it and observe what's going on your graphing calculator. Let's look at it. So you can either plug some number. You said this shows, what if I had been going x equals negative infinity? Then I would have plugged a negative 100 in there and see what kind of value I would have got. But you can always just go to your trusty calculator. Okay, as you can observe, as x goes to infinity, where's that going to? That keeps going and going, don't it? So that's how you get infinity. So you can either do it two ways. If you can't see it by plugging a number in, plug it in your calculator. All right, number 8. What's my degree in the numerator, Conley? 2. My highest degree is there. What's my highest degree in the denominator, Reese?
2.
So my degrees are the same. So what do you do with your leading coefficients? There you go. 3 halves. Here, what's my highest degree in the numerator, number 9? Very good. What's my highest degree in the denominator, Zach?
1.
Okay, so what am I going to do with the leading coefficients, Big T? What's 4 divided by 8? Give you. Yep, that's your answer. All right, number 10. What's my highest degree in the numerator, Sean? 1. Very good. My highest degree in the denominator, Grayton? 2. So it's top heavy or bottom heavy? So when it's bottom heavy, what's your answer? Here's your answer. That is our learning target for the day. I can determine limits at infinity. Are we good on that? Can I see a hand signal? Let's go and do our homework, go over the answer so you don't have any homework. 41 to 51 odd, and you have 14 minutes. I'm going to give you guys probably 8 so we can go over it so you have no homework on this happy Monday morning. Make your day long. You can spend time doing English, AP English, and AP History. Yes. So what we did, remember, so once you did, here's the person you did, plug in the thing. Let me show you the card.
On 42, how are we supposed to know what power we have?
Yeah, I didn't like that problem. Skip that one. Just skip it right now. Oh, well, you could just wait. 41 through 51 odd. Thank you. And you can always graph it as well. Where's my... Guys, what are you doing? It works now.
Okay.
So I don't confuse it.
Okay, but if you have to choose the number, that's what it is.
Yes, that goes to infinity. It goes to infinity. Look at our X. Just going where? You see that? Look? Look up when you're done, okay? I'll give you a couple more minutes. If you work with me this week, you got no written homework the entire week. All you have to do is study for your test on Wednesday. Because the stuff's so easy, it doesn't take you 8 minutes to do it. All right, let's go over these. Number 41, we have a rational function, and right here, when you're going to infinity or net infinity, you're either going to sketch a graph or you got your rules here. Okay, this is rational. My highest degree in the numerator is what, class? 2. What's in the denominator? So what do you do with your leading coefficients? Very good. Now 43, is this a rational or polynomial? So I need to sketch a graph. It has, what type of function is this? Quadratic. Leading coefficients what? So it's going to be going upward. As I approach negative, as I go to negative infinity, I'm going that way. What's happening to my y values? They're going where? Positive. Very good. Number 45. My degree in the numerator, my highest degree in the numerator is what, class? 2. Denominator is what? What do I do with my leading coefficients? Divide. Doesn't matter if I'm going to negative or positive. If the degrees are the same, you divide the leading coefficients. Alright, number 47. What type of polynomial is this, guys? Cubic. The leading coefficient is? Is that important to know? Yes. Now I'm going to sketch my graph. It's going to be something like this. As I go toward negative infinity, where are my y values going? Very good. Number 49. What's my highest degree? 3. What's my highest degree in the denominator? So I'm top heavy, aren't I? So this is the tricky ones that you can, okay. I'm going to pick some number going to infinity. What's the number going to infinity?
1,000.
1,000. I like that, the big number, easy number to work with. If I plug 1,000 there, am I getting a positive or negative value? I'm getting a what, guys? Positive. And so it's going to positive infinity. If you don't see that, then you can graph it. You said, Mr. Chester, I was thinking everybody asymptote in there. If I get a straight line like that, it means there's a hole somewhere. Something. Okay, so as x goes to infinity, what's going on in my y values? They keep going where? They keep going where? Positive infinity. All right, number 51. All right, what's my highest degree in the numerator? What's my highest degree in denominator? I'm top heavy, aren't I? Okay, as n goes to infinity, I can pick another number, 100. If I plug 100 in there, will that give me a positive or negative value? So it's going to what infinity? Or you can graph it. If I was to graph this function, okay, look at this one. There's clearly an asymptote right here somewhere. But you look, as x goes to infinity, where does this keep going to? Positive infinity. Does that make sense? Very good. Let's get our math workshop back out. We got 5 minutes. We can finish it. You're not going to have any homework, so please don't get upset that we're going to keep doing something right now. If you're done with homework, you just have to review. Okay, let's finish these last 3 on this math workshop. I just can't sit here outside. Alright, so these permutation combinations. Remember, permutation is place, combination, you're choosing something. So number 19, I'm selecting 9 books to check out of the library from a reading list of 12. That's not choosing something, is it? So would that be a permutation or combination? What is it? What is it? Good. So let's write this. So combination, I put a C. How many do I have to choose from? I have 12 to choose from, and I'm selecting how many? 9. Now you can just put in your calculator, if you remember where that button's at. Go to math. A lot of things are under math, so if you ever forget something, it's probably under math. Probability. Oh, I think I need to put 12 first. No, I don't. You might have to in your calculator. Sometimes you have to put the first number and then hit the button. I think mine is the other way around here. Probability, I'm going to hit 3. I got 12 and 9. And I get 220 as my answer. Make sure you get that. Now I'm going to come look at your calculator. 220. Zach, go get your calculator, buddy.
I got one.
Okay. So your answer is 220. Did everybody get 220, or do I need to come help you with your calculator? All right, number 20. Choosing 2 CDs to buy from 10 on sale. Does order matter here? No, I'm choosing. Choosing. Order doesn't. Remember, permutation order is important. Combination order is not. But that's how I remember. Permutation, you're placing something. Order matters. Combination, you're just choosing. So once again, number 20 is a combination. Okay, how many do you choose from? 10. How many do you want? 2. So I set it up like that. 10C2. Oh my God. 10, 2, and I get 45. Number 21. 7 shoppers in a line. Would order matter here? Yes, you play. Because I'm going to tell you, when you're in a Walmart checkout, it does matter if you're the first or the fourth, don't it, at the time. So order matters. So this is permutation. So I have 7 people to choose from, and I'm putting 7 people in the line. And I get 5,040. And that is my answer. That's that many different combinations. Like I can have 5,040 different ways, 7 people in 7 lines, 7 people in a row. There's 45 different combinations of choosing 2 CDs from those 10. That's what those numbers mean. Enjoy your no written homework night. Just study for your quiz. You won't have any homework tomorrow night. Get caught up in some of your other classes. Big T. Read a book. Read a book. No. Read a book. So you don't. I'm not giving you math homework. Just read a book. Catch up. Read about the New Deal. Review your history. Do an experiment, science experiment at home.
What GPA scale is class based on?
I'm just like an AP.
So like the 4.5.
If you, what is the AP class? You get a bump and a half. That's what you get in dual enrollment. Dual enrollment is just like AP. So if you get like a point and a half a class, it's the same way.
So like so if I had an A in here, what would my GPA be for this class?
Like a 5 point something.
Well, they scaled mine as a 3, like a regular class.
Dual enrollment, was it weighted, unweighted?
Well, I think it went from a 4.4 and you'll see when I was a 3.
Go ask the counselor. Go ask Miss Miles about that. What now? Well, it's supposed to be the same as AP. You get the bump for dual enrollment. I'll go check on that for you, okay?
Well, me and my mom were looking at my transcript and there was no way my GPA would drop 5 points.
Okay, I'll look at it. I'll go in there and just look at it. Don't y'all get a bump and a half of AP? Y'all have a great day. Morning, Will. How you doing? How you doing?
I don't want to get these sheets of paper. I already just seen the people docs and I can print it out myself. Yeah. No, it's not bad. Like, I did it yesterday. I mean, it's not gonna do it. What we throw that? Waste. Fantastic. How are you? You can't type on the marking screen. She said she was gonna go. She said she wasn't like around the part 1 test yet. She said so she's gonna go. She said part 2.
The World of Math. You smile when you come to the World of Math. Look, that skin don't look bad. That look like that looks slim straight on it. Good morning, good morning. Here we go. Limits, limits, limits. Good morning. Good morning. Here we go. Here we go.
Mathematics emporium. This is no longer Mr. Esther's classroom, it's the mathematics emporium. Straight up
Oh, you just right? I'll put it in the Good morning. Good morning. They're really not doing it.
You want to choose that?
Happy Monday.
I'm in a great mood. Hope everybody is.
Did you have a pretty rough weekend? What happened?
Passed out.
Oh, God.
I'm exhausted.
Oh, Lord.
Overeating. It was great.
All right, let's turn to our math workshop from last week. You don't need another one. Still have this one. We're looking at numbers 13 through 18 today. Let's go on doing 17, 18. We're going to come back to 13 to 16. But 17, 18. 17, it says, a video store has 8 new releases this week. Each is available on videotape and on DVD. It's 2 different formats. How many ways can a customer choose a new release in a format? How many movies do they have to choose from? 8. How many different formats? So how many different combinations? 16. And why can we do that? The fundamental what? Counting principle. Very good. Number 18. Okay, we're on number 18. Number 17 was 16. Look at number 18. The menu for a banquet has a choice of 2 types of salad, 5 main courses, and 3 desserts. How many ways can a salad, main course, and dessert be selected to form a meal? What did I do with those 3 numbers? Multiply. What's my total different combinations? 30. Very good. All right, let's go back to 16 through 13 through 16. Inverse trig. Inverse trig. Let's review where these things occur. Inverse sine comes from what quadrants? Quadrants 1 and 4. Arc cosine comes from what quadrants? 1 and 2. Do they include 0 and 180? Yes. Going back to sine. Does sine include 90 and negative 90? Yes. Arctan occurs in what quadrants? 4. Do they include 90? Do they include negative 90? No. Okay. So let's look at, I want you to try those 4 right now. Try those 4 right now. I'm going to give you 3 minutes. Now, if you need to work with your group, you can. This is not a quiz, and this is not a checkpoint. Max, they have you marked absent for some reason. Were you tardy first period? Okay. Run down there right now and get that fixed, or you'll be marked absent all day. You know what I'm saying? Just say, hey, Mr. H knows I've marked absent. I was just tardy this morning. Okay? Say it nice and polite. Okay, looking at the board, guys, for upcoming dates, the only thing you have this week is a quiz. Your next test is next Tuesday, so this is a great week to study and get any makeup work or any test corrections that you need to do. Remember, you can do test corrections on 2 tests that you make under a 70, but your maximum you're going to make is a 70. Okay, because that's fair for that's only fair for the ones the guy that made a 73. You're not going to make higher than them. So the maximum you're going to get is a 70. You get 2. Some of you need to have both of those done by the latest test correction be 0 period Thursday. Does everybody understand? So you need to be studying that this week. After the Thursday, there won't be any more test correction on any test that we've taken before. And Lucy, you turned your homework in. Bring that here, and here you can take this quiz quickly that you missed on Friday. All your grades are uploaded. Let's see how many grades you have right now in this class. Here. Right there. Thank you. We're almost to the halfway point of the 9 weeks. Power Sports got next Friday. Your grades are updated. And you have one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 assignments. I think that's a good amount at the moment. Now this week you will have a few checkpoints. You have 2 checkpoints and a quiz this week. And always on the last day of the week, that's when we're going to do a homework check. So if you miss homework one day a week, you just got to get done by the end of the week. You got me? But I strongly suggest you do it every night because you don't want to do all that on come Thursday, on Wednesday night. Y'all understand? That's just in case you get busy. I started doing that so you don't seem stressed. Matthew, you okay? What's wrong? You look like your dog ran away or something.
No.
All right. And Lucy, after you finish that quiz, you're going to erase your name on the board, okay? All right. So, the arc sine of 0, what would that be, guys? 0, because at 0, your y-coordinate 0, isn't it? You wouldn't put 2 pi, you would put 0, because 0 falls between the interval negative pi over 2 and pi over 2. Does everybody understand that? All right. Number 14, the arc cosine of negative 1. Where's cosine equal to negative 1 at? Pi. That would be my answer on number 14. Are there any questions on 13 and 14? Number 15, arc tan of negative 1. Where does arc tan live in quad? 1 or quad? Remember, tangent is y divided by x. Is this going to be one of your major points? No, it's going to be one of the reference angles. Which one? Pi over 6, pi over 4, pi over 3? Pi over 4. Now, we want the negative. So would that be in quad 1 or quad 4? 4. Would it be okay if I put 7 pi over 4? No, because remember, arc tan is defined from pi over 2 to negative pi over 2. So what's another way we can write 7 at pi over 4? Negative pi over 4. Remember those, you have to write them a different. Thank you, Lauren. That's negative pi over 4. Number 16. Arc tan of square root of 3 over 3. Where does that live in quad 1 and quad what? 4. Quad 1 or quad 4. It's positive, so it's mean quad what? 1. Would that be pi over 6 or pi over 3? Pi over 6. Are y'all good on those? Y'all understand that now? Because you've been against that and you're not losing. Alright, how's ACT this weekend? Who took it this weekend? Was it easier than the one you took at school? I don't know why they make the one at school so hard. Last year was hard. But remember, the one that trained us said that math is always the easiest. April, for some reason, June and December. April, June, and December. Alright, here we go. Let's look at homework page 11. Tomorrow you have the quiz I was going to give you Friday, but I didn't feel like you were ready for it, so it's going to be tomorrow. We're going to do a big review today. We're not going to learn anything new. I'm just going to give you problems and say, what do you do? What do you do? What do you do? All right, now, so far this is what we've learned, so let's look at our learning targets. We've learned to find a limit by using a table, by using a graph. I feel like you're very good at this. Very good at this. Graphing. Okay? I feel like you're good at this now. So we know what to do if we give a graph. Okay, I can find a limit of a function algebraically. We always do what technique first? Direct what? If that doesn't work, then you try what techniques? Factoring. Common denominator. What's another one? Rationalizing. Very good. Okay. If that doesn't work and you still get zero denominator, that's when you go to, okay, if it's one side, you got to pick a number from that side and plug in and see what infinity it's going to. If it still don't work, it's two-sided, do you have to pull one from each side? Yes. Do y'all remember that? What type of limit is this? One-sided or two-sided? Two-sided. How about this? That's two-sided. What if it has this is one side is, and if it's over here on past, that's negative 1 is, so that's two-sided. Do you see that? That is one side because I'm only concerned with going from what direction? Coming from the what? And here's coming from the. You see, these are one side, these are two sided. You see the difference? Okay. What do you got? 33 through 40? Wait, no. Okay. Thank you. Let's see here. Let me find one of these. Alright. Look at 29. Okay, this is a two-sided. These are one-sided. Wouldn't it help if we did these first and then made our determination on A? That's what I would do, guys, if I was you. Alright, so here, I want the limit as x approaches 1 from the left. Which one of these represent the values to the left of this point of discontinuity here? Top or bottom? Top, so I'm going to do direct substitution. 2 times 1 is? 2 minus 2 is? Okay, now this one's from the right. This represents the right. Negative 2 times 1 is? Negative 2 plus 2 is? Did I get the same value? So what would my two-sided be? Very good. I need to record this. Oh, I'm still recording from last class. Oh.